Hi, this is Kyle from HHSmithy. We recently showed you how Bodog's all-anonymous tables expose user IDs to the client. The attack vector is basically identical to the PlayStation 3 hack that sidelined the PlayStation Network for months. Bodog trusts the client with data it shouldn't have. It's obvious that this data could be used to track players using tools like Poker Tracker and Hold'em Manager. However, posters on 2plus2 were wondering why I said that this represented a huge security risk. This video is meant to explain how Bodog's exposure of user IDs is a vulnerability. How Bodog handles logins is mostly secure for any given single user, but on a widespread basis, it ends up being insecure for the whole population. First of all, they have very lax password standards, allowing people to set 6-character passwords without special characters, numbers, or mixed case letters. Secondly, their web login form is attackable via the shotgun method. They lock out repeated login attempts for a given user ID, but they allow a computer to make attempts from the same IP on a different user ID. I'll show you how that works. For those wondering, these accounts are registered to me, so it's not that hacking anybody else. Go ahead and try to use bogus passwords. You can see it's rejecting them. And it gives me this lockout screen. So I'm going to go back to the login page. I'll use a different one. Shows that this is an error page again. Do this again. They're letting me make multiple attacks on multiple accounts. This is obviously a problem. So let me show you some basic pseudocode that shows how this exploit might work. What you're going to see here is a username and password global list. A hacker might put together a ton of usernames using a tool like Pretacrasher and list them all into a single array. Then they'd have a dictionary of word lists that's just going to have all the passwords that might possibly be used, on any given user. So password, Bodog Poker, bad beats, so forth. You can have functions here that makes an attempt on a Bodog login, gives a user password, it checks for the failure string, submits a form on the web form that's attackable, gives it the user password. If the response is a failure, it returns false, so that user and pass has failed. Otherwise, return true and it's hacked. This function is basically just the encapsulation function for hacking a user. If it's true, it shows the broken password, gives the username, shows the password, displays it there. This is the main function, and this is basically where all the logic is. It's just 2 nested for loops. You have a for each. So for each password as a pass in the array, you select a user. So basically, you're going to try the first password in this array on every single username in this list. This way, you never get locked out on any given user. You can try the password on all 500 users that you have, and then when that fails or it cracks some of them, that post, that's fine. And then you try the second password on all the users that are in the list. Better logic would strip the users that have obviously been authenticated, so you're not making attacks on something that doesn't exist. They don't lock out on IP, but even if they did, it would be trivial to write a script that cycled through proxies that would, make this attack still successful. You can see more of this at hhsmithy.com/blog, or click the link in the description of this video. With legalization of online poker on the horizon in the United States, the need for independent analysis and security vulnerability research has never been greater. Demand it.